Okay, welcome back to the next video about subnetting. Okay, I wanted to show you something. Unfortunately, because I'm not in at the college, I can't get a picture of the actual servers. I suppose I could probably find one right here so you get an idea of what we're talking about. It says 224M. So we have a bunch of these servers that are sitting down in 119A. Sorry, I got the wrong thing. Oh, but this is almost fine. Okay, M4. I think this will be fine. Okay, so what we've got is we've got a bunch of these servers. This is what they look like. So we've got five of them sitting down in 119A. That's the thing that looks like the big fish tank down the first floor. And what they are, these are big servers that you can put a lot of virtual computers inside. Okay, and this is actually what the programming interface looks like. And you can see that I've got a bunch of things called virtual machines. So what these are, I've got a Linux machine in here, I've got a Windows machine, I've got an Ubuntu Linux, I've got another or other Linux, I've got Ubuntu Linux. There's lots of Linux machines. We tend to use this for our Linux courses. And you can see here that there's a total of 38 of these things. So if you scroll down, you'll see that there's another 38 of these computers. And of course, the thing is every one of these computers you need to access remotely, which means that they need to have an IP address. Okay, so now here's the first question is how many computers can we possibly put onto each one of these servers? Well, it depends on how much CPU and how much RAM you want to give the computers, but generally you can manage to squeeze about 80 computers onto a single server. Okay, now think about this. If we have a total of five of these servers running and each one can hold 80 computers, I'm talking about having 400 computers on a single network. Okay, so how do we organize this type of thing? Okay, well, imagine this. Suppose I wanted to start picking some of those numbers like 192.168 dot, say 30 dot something slash 24. Would that actually give me enough computers? Well, remember what a slash 24 means. It means that for my network, I'm talking, sorry, 1, 2, 3, 4, 5, 6, 7, 8. I'm talking about having network masks that look like this, 255, 255, 2550. Remember, if I have this, how many computers can I have? Well, I can only have 254, and yeah, that's just not going to, it's not going to quite work. Now, what about if I was to, say, use one of those Class B networks and go for a slash 16? Okay, what I'm talking about here, I'd be talking about taking these things and using these as the host numbers. Now, how many computers could I have on a slash 16? Well, now I can have like somewhere in the range of about 65,000. Well, that's kind of ridiculous because I'm not anywhere near that type of a number. Okay, so what did we end up doing in order to organize the college network? Well, rather than using a number like this, rather than using 24, a decision was made to use the number 23. In other words, what we're talking about is these 1, 2, 3, 4, 5, 6, 7 would be part of the network, and everything else here happens to be the host. Okay, well, let's actually turn this number into some binary values, so at least we can take a look at it, and then we can talk about the binary values for the host, so we can see how many we really have. Okay, so first of all, let me write up the number 192. Okay, so this is going to be, let's take 192.168.30.1 because we know a 0 is definitely not going to work. Okay, so we're talking about 11000000. Okay, the 168. Okay, this is 10101000. 30. Okay, 30. This is the number 00011110. And finally, 1 is 00000001. Okay, perfect. So, what this happens to be the part of the network. So notice that this is on the network. Now, let's do the same thing as what I've done before. Let's start copying and pasting some values to take a look. And let's just try the next value, number 2. Okay, well, the number 2 is going to look like this. And the first question I'm going to have is it on the same network? And the answer is, yeah, absolutely it's on the same network. In fact, it's going to be on the same network now for a fairly long time. Okay, 168.30.3/23. This is going to look like this in binary form. Okay, and notice that, again, we're going to be here for a while. Okay, so what is going to be something that looks like, say, the broadcast address? So first of all, we know that the network number is quite simple. This is not the network number. It's going to be all zeros. The broadcast address, on the other hand, is going to end up looking like this. So let me copy and paste the entire thing. Okay, so what we'd be talking about. Okay, so let me put a question mark here because I'm not going to do this quite yet. This number followed by a bunch of ones, that happens to be the broadcast. Okay, so this is the broadcast. So what number does this actually look like? Well, notice that I changed this number right here. Okay, so really this is not 30 anymore. This is now turned into the number 31, and this is 255. That's actually the broadcast address. Okay, so it's 31. So in other words, we've set it up exactly like this. And now it's sort of too bad because if you were to get into the classrooms right now and take a look at the network mask, you would probably find it actually looks like this. Okay, well, let's make a prediction. First of all, what does the subnet mask look like for /23? Let's actually write it out in decimal form. Okay, well, we know that it's a pile of ones at the beginning, so it's in binary. It's going to be 8 ones here, 8 ones here, and it's going to be 7 ones here and a bunch of zeros here. So what is this value? Well, that's definitely 255, 255. Now, what is this number? Okay, well, let's find out. Okay, it's the number 254, and that's a 0. So that is the actual subnet mask that's going to be used in almost everything that we've set up. Well, let's see whether or not this is the way how things are actually set. Okay, so in order to do this, let me go back to my server for a second, and let me take a peek at, let's say, I think maybe under the word host, I will see what I'm looking for. Okay, let me see if I can spot it. If not, okay, well, take a look at this. So recognize the default gateway, something dot, okay, so 192.168.30.1. Okay, now, unfortunately, what it doesn't show me here is it doesn't show me the actual IP address. So is that actually hiding somewhere? You see, I've got a host name, yes, because we are using DNS. Let me see if I can manage. And I should have looked this up beforehand. Okay, if I can't find it, you know what? I'll simply throw this away because I've got other places that I can look at this. Okay, let me, for example, pop open the command prompt. Okay, command prompt here, and let me type the magic words ipconfig, and let's take a look at the IP address of this computer that I'm on right now. Okay, so what I've done is I'm remotely accessing this computer that happens to be sitting in my office, and take a look at the IP address. I've got a 192.168.10.26. Okay, that seems to match. And take a look at this. I've got the net mask of 255.255.254.0. In other words, what we're talking about 23 ones followed by 9 zeros. Okay, and the reason why we did this was so that we could end up with a bunch more computers. So how many computers in total can I have on the network? Okay, well, in this case, because I've got a total of 9 bits, well, we can do the same types of things what we've done before. It means that the biggest number is 511, which means that the biggest number would be 500. The biggest non-broadcast 510. So this means we have a total of 510 computers, which happens to be about the right number for this type of a setup. Okay, so that's actually the reason why we've done this. Okay, once again, I'm going to stop this video. I'm going to be back in a couple of minutes, and I'm going to give you some small exercises to work out. Okay, so check back on the actually, I'll make it a completely separate video. Okay, so please read the next, or please watch the next video. That's where your exercise is going to be.